Hi there. Having spent some time looking at MIDI out from Sonic Pi, I've turned my attention to looking at MIDI in this afternoon. I had great fun connecting up my Oxygen 8 MIDI keyboard to Sonic Pi Dev version 2.12, and it gives some really fantastic things that you can do with it. I thought I'd start off just giving you a demonstration of some of the things you can do, and then we'll zoom in on the screen and spend a bit more detail on the program, and I'll publish the program so that if you want to have a go yourself and you've built or have a copy of the Alpha MIDI 2.12, then you can do so yourself. First of all, we can use it as a straight keyboard. Let's just start this running. There we go. It's now running and it's waiting for some keyboard input, so let's give it some. I can choose the synth by using one of these knobs here, and you won't be able to read it at the moment, but on the screen here it's showing me the current synth that it's chosen. So that's a beep synth. Let's just go up an octave or so. The keyboard is essentially monophonic. If you play two notes, you'll probably get them both about to sound together. If you try playing three or more, it doesn't really work. So the way that it's actually analysing the information that's coming in, it can only really deal with one at the moment, one at a time at the moment. However, I can do some control on the note. I've set up two of the knobs here to control the sustain and release times of the note. So if we turn the release right down and the sustain right down, we won't hear anything. But if I turn up the sustain a little bit, we're getting a very short note. If I turn up the release, you can hear it continuing for some time after we've played it there. Let's try one or two of the other synths that we've got here. We've got Profit. Turn up the that's down an octave for that. I'm actually playing in the program. I'm playing the keyboard notes inside some G verbs, so it sounds a bit nicer. But of course, that's all under the control of the program, so it's very easy to alter what things are going to sound like. Now let's try another synth. We've got a piano here. Old favourite Ferrajaka. Let's go up a bit further, and we've got Zawa. Perhaps just reduce that a bit. And we go right up to the top, we've got Mod Saw. As well as the playing on the keyboard, I can actually generate notes and control them using the modulation wheel here. And I'll just turn up the volume of a note which is already running. There it goes. And if we adjust the cutoff of the note, you can hear the effects of that. And I can actually adjust the pan of the note from full left. You can see on the scope there, one trace is showing a large thing, nothing on the right hand side. That's now in the centre, that's now on the right. And we can play along to that. What about some percussion? Let's just play a little loop. Or a different one. Or you can indeed make drum your own rhythms. We fade that note out a bit. Let's just try some. So I hope you can see that we have really great versatility with Sonic Pi here. Great versatility in what we can do, and you can have a lot of fun with this, using this as a basic instrument that you can play in Sonic Pi alongside other things that are actually happening, like some There is a little bit of latency. I've reduced the set schedule time to 0.1 seconds, which makes it a bit better, but it is slightly behind the keyboard, what you're generating in Sonic Pi in the program. But if you're doing this accompanying, it's fairly easy to actually keep in time with that. So I hope you've enjoyed this. I'm going to stop this now and we'll switch to the full screen and we can look at the program in a little more detail. Thanks for watching this section. Hi, welcome back to part 2, where I'm going to look at the program in a little more detail, such that I hope you'll be able to read what's on the screen. We'll make that perhaps a little bit bigger there. As it says, this is an experimental program to try out MIDI in with Sonic Pi 2.12.0-midi-alpha3. And I'm using an Oxygen version, keyboard version 2, which is connected to the Mac, and this sends out MIDI signals which are picked up by a little program called M2O, which is a module of Osmid, which is a little utility that converts MIDI to OSC or OSC to MIDI, which is written by Louis Lauret and is incorporated in Sonic Pi in the latest version. You can see how to use it by looking at the README file for Osmid, which I've actually got open here. And this describes a little bit about Osmid and the two parts of it, M2O, which is what we're using, and O2M, which is used when you want to send MIDI out from Sonic Pi to an external DAW or program which you want to play MIDI on. Osmid had various parameters, the main ones of which are that you have to specify the these are specified in fact automatically by Sonic Pi when it sets it up, but the important thing is that it receives MIDI messages in this sort of format, /MIDI / a port ID. This is actually the device number to which you're going to connect, and in my case for the option it is 2, and then the channel, which will be 0 up to 15 depending on which channel you want to use, and I'm going to use the first channel, which actually comes down as a 0 there. We can check that also by looking at a terminal window, and I'm actually, if I look at the listing of that in the window within Sonic Pi, where these two utilities are stored, M2O and O2M, and if we start up M2O with the parameter -L, then that's going to list all the connections that it makes. It connects to basically any MIDI input that it can see, and you can see that the USB Oxygen keyboard is connected to as device 2 there, and that's what we're going to see when we start getting messages coming in from it. So we'll just stop that and come back to here. The other thing which is very, very useful if you want to learn how to use this is to look at the logs in Sonic Pi, and I've also got those open, or the relevant logs, which is the Osmid M2O log, and you can see here some of the messages which have been received from a previous run. It receives the message MIDI to 0, and then a control change. That's one of the ones I get when I twiddle one of the knobs on the keyboard that we saw a bit earlier. If I just twiddle one here, you'll see some more information coming in at the bottom of the screen there. See that one, knob 32, is set to value 10 7, and if I control the modulation wheel, which is control number 1, you can see that goes up to 127 at one extreme and down to about 0, if I can get it to just catch one of these near the other. It's going down to 6 there at the other end, triggering those. And you can see that that's how we know that it's a control change coming. First of all, it's a MIDI signal. It's from device 2. It's on channel 0, or the first channel, and it's a control change message. If I was to press the keyboard, then you'll see that we get the message MIDI 2.0, same device, channel 0, and it says note on. It always uses note on, and the way it turns the note on is by having the parameter for the note turning on, the second one here. This is note 60, which is a C. The parameter turning it on is with a velocity 62, that's about half volume. And when you let go of the key, it sends a note on message but sets the velocity to 0. And if we use this second parameter to control the amplitude of the note, we can actually turn it on and turn it off as the key is pressed and when it's released again. And so that's essentially, in a nutshell, how we're going to detect the various signals which we're going to see. So let's move back to the program now and see what happens. Well, there are lots of different control signals which can be produced by the keyboard. If you remember back to the first part of the video, you saw that there were some rotary knobs and there were also the modulation wheel, and there were some buttons which I had set up to play various percussion instruments or loops, percussion loops. And each of these has a control number. And the ones I'm actually going to use are signified on this line in the program. I'm just giving them initial values to set up. First of all, I'm defining an empty list K, which is going to hold pointers to these various controls. The numbers are fairly arbitrary. It just happens to be the default numbers which are assigned to the controls on this Oxygen 8. They could be anything you like, really, as long as each one corresponds to a particular knob or button that you're going to use on the keyboard or device which you have. And I'm setting up the control 1, 6, 32, 74 and 52 all equal to the value 0.48 to start with. The reason I've chosen is that for the note value here, 0.48 is going to end up giving us a note of 60, because each of these controls actually has a raw input range of 0 to 127. I guess scaling them from 0 to 1 by dividing by 127 here. That's what this function norm is going to do. And therefore, if we multiply 127 by 0.48, we'll get 60 near enough, which is going to be that particular note. As far as the others are concerned, it doesn't really matter what they are, as long as they're not nil. We want to have a certain value in there. And I've set the values for 71, 20 and 83 equal to 0. 83, I think, if I just turn it again, yes, 83 is the volume knob of the continuous note. I'm setting that to 0, so it's off to start with. And 20 is the, which one is that? I don't remember which one is which. That's one of the percussion ones. At least it shows you that it works. We'll come back to this. I can't remember which choice. Oh, so I put them down here, what they are. Here we are. K20. I haven't actually got it there, so I don't know which one that is. It doesn't really matter, though, because it'll come out in the wash when we see the program running. Now, I'm setting the synths which were playing the continuous note, the one which is controlled by the modulation wheel, to be the TB303 synth. It could be anything you like, but that's quite a reasonable one to use because it responds very well to variations in cutoff. I've then got a selection of a synth list which has got 6 different synths in it: Beep, TB303, Prophet, Piano, Zawa and Mod Saw. And I've set up a scaling here, which means that as I turn one of the control knobs, this knob here, C1, it's going to actually change which one of these it's going to be. In fact, I think that's what K20 is there. That's that one there. And it's going to scale 0 to 1 to give values of 0, 1, 2, 3, 4 or 5, switching over as we turn around. And that's done by simply multiplying the value of V, which is 0 to 1, by 10. So that's going to give you a value that goes up to 10 or just over 10.1. And then I'm going to do an integer division of it by 2. So that's going to give us the values of 0, 1, 2, 3, 4, 5 as we increase the values here. And that's going to be used to choose out of this list which synth we're playing with. The next live loop here, which is called CC, is the control change loop, and that is going to read in the data when we change any of the knobs that we twiddle here, and it's going to store the relevant control information into the relevant K value here. If I just take one of them, let's say this one here, and I turn it, this happens to be control number 6. You can see its value goes from 0 up to 1. That's the scaled value. The raw value goes from 0 to 127. And control 6 is actually the pan control, which I'm twiddling here. And so that stores the current setting in K6. Conversely, if we take the one which does the cutoff, that's control 32. That's equally going to control those values, and the others you can see are going to be likewise. This one here is going to control the synth selection, and rather than print it, what I've got it to do is to say that if we're playing around with knob number 71, then it's going to print out the selected synth that it chooses using synth choose. That's this function we had up here, applied to that list of synths here. And it's just going to print the current one. That's so that I know when to stop twiddling when I've got the synth I want. You can see as I turn it round, it goes through the 6 possibilities. All the other ones just show me the actual value that we're setting this to, like that. Okay, so that's what that little live loop does, and it's set to pull every 0.01 of a second. That's going to be actually in seconds because we've got the default BPM in operation. And here's where it prints the values on the screen, the control that we're twiddling, what its raw value is, and what its normalized value is in the range 0 to 1. Then we get on to the live loop, which is going to actually play the continuous note. And the way I do that is that I start first of all selecting the synth, which is TB303, set further up. Then we're going to start playing a note whose frequency is given by the modulation wheel, which is K1. And we're going to make it last for 1,000 seconds, starting with an amplitude 0, so that there's no click as I start running it. If we just stop the program running, which I'll do here, and start it running again, you'll see that we don't hear anything. That's because I've got the volume adjust knob of this set to 0. And having started it playing for 1,000 seconds, we then have a loop that goes round, pulling every 10th of a second, and it's going to control this note, and it's going to set the pitch of the note equal to 100 times the K1 value. So that's going to go from 0 up to 100. It's going to have a nice note slide of a 10th of a second to smooth out the changes. It's going to have a cutoff, which is going to range from 20 up to 80 times the value of K32. That's the cutoff control. In other words, it's going to go from 20 to 100. Again, the cutoff slide of 0.1. The amplitude is set by control 83, and that's just going to go from 0 up to 1, again with an amp slide. And the pan is going to be 2 times the value of K6, so that's going to go from 0 up to 2, minus 1, so it's going to go from -1 to +1, again with a pan slide. And that's how we can make all the controls of that note. And so if we turn up the volume of it, we can adjust its position here and the pan value. These interact, of course, and so for certain frequencies, if you put the cutoff too low, you won't hear anything. As I raise the cutoff, we can hear the notes coming there. It shows very well how the cutoff works there. That's with a high frequency note, and we're raising the cutoff until it gets right up to the top. We don't actually get much coming through. If I reduce the frequency of the note, we get a peak further down. Several peaks, like that. And we can, while that's on the screen, we can see the effect of changing the pan value. If I put it full right, then we've got the bottom trace showing a large amplitude and the top trace, which is left, showing nothing. We go back to the centre and then out the other way. We can alter whereabouts the sound is coming from. And you can see that control 6 changing on the screen below as we do that. Let's leave it back in the middle and let's just reduce the frequency of that again a bit and take the cutoff value down, and we'll fade that note out. So that's that section. The bottom section here is to do with the live keyboard loop, which is in here, and you can see that the whole thing is inside a G-verb FX, and that's going to give a nice resonance to the notes that we play. So in this case, we are looking not in fact for and in fact, I missed out this section up here. The important thing here is that we need to wait for, in that case, MIDI 2.0 control change, and that will trigger out that loop. Down here, we're waiting for the message MIDI device 2 channel 0 note on, a note on message, and we are going to set the note value equal to the value that we've picked up. That's the next parameter, and we're going to set the velocity to the normalized version of the third parameter. So that's going to go from 0 to 1. This is just a raw number which is going to go from 0 to 127. So the pitch can be anywhere we like between 0 and 127. The normalized value will be between 0 and 1. And then we're going to use a synth command to play the current synth, which is selected here, as we discussed up above, from the list SL. We use synth choose, which applied to the value of K71, and as K71 goes from 0 to 1, that will go 0, 1, 2, 3, 4, or 5, and select one of the synths in that list. Then the note is played with value N, which we just specified here. The amplitude is V, which we specified here. And the sustain value is given by the raw value for K74, which is going to go from 0 to 127, 0 to 1, sorry, that's a normalized value, 0 to 1 multiplied by 2. So it's going to go from 0 to 2, and the Reese value similarly is going from 0 to 2. We could make these longer if we wanted to. And this is going round with a very short gap so that we get the best response we can from the keyboard for the note control. So that's how that works. And if we look over here, we can see when I play some keys, oh no, I've not actually specified them to come out there, but we could, if we want, just take out this line here, and we're going to look at the entire message which comes up for this one. So I'm going to stop and rerun that. And now if we play this, you can see the entire message coming up here. This is going to be device 2, USB, oxygen, and it's not actually displaying here the channel, but it is channel 1, or the first channel. And then we get 67 is the note, 79 is how hard I hit the key, and then that turns it on, and then when I release the key, that turns it off again. I'm going to hit a key hard, and you'll see that this one gave us... go around the loop too many times, but if we go up to where it actually turned on, let's see if we can see it there. 113 was in fact the velocity which I had. It's going around lots of times and playing the note several times over there. But if I just do a short one like this, let's go that back again. Let's just stop and play again. Stop and play again. Let's play that with one. You can barely hear it. Now, if I turn the sustain and right down, it's still playing the note, but you can't hear anything because there's no sustain value, no release value. Turn it up again. That's a short sustain, no release. That's a short sustain and a longer release. And if we change this on the screen, you can see we're changing the keyboard, the font, the synth. So that's the keyboard section. The final section is the percussion section, which I call bong in the live loop. This is going to be another control change, but I'm dealing with this separately, so I've simply asked this to be triggered by a sync when it gets a control change section, and these are the various possibilities. We can play an electric bong, percussive snap, BD house, drum cymbal closed, loop arm end full, or loop mica at various amplitudes. And in the first one is played if the control change, that's the first parameter after this, is 20 and it's pushed, that it will have a value of 127. It has a value of 0 if it's not pushed. So if button number 20 is pushed, then that will do an electric bong like this. If button number 21 is pressed, this gives a percussive slap like this. If button 22 is pressed, we'll get BD house. Button 23 is pressed, we'll get drum cymbal closed. And if the next one is pressed, we'll get loop arm end full. The last one is pressed, we get loop mica. So that's the whole program, and just playing around this afternoon, that's what I came up with, and I hope you've enjoyed having a look at it. I will publish the program on my GIST, so you'll be able to have a go at it there. Thanks very much for watching.